help is being pledged for India as it battles a ferocious second wave of coronavirus, described by Prime Minister Narendra Modi as a storm that has shaken the nation.
This is Delhi. On April 2nd, 2021, India's capital, Delhi, faced its worst wave of COVID-19, averaging over 100,000 cases daily. Both crematoriums and hospitals were overwhelmed. As a result, oxygen supply in Delhi became scarce, and people had to wait and pay exorbitant fees for their share of it. Even worse, India's major oxygen companies are located in the south, meaning that oxygen would have to be transported for days to reach Delhi. The lack of available oxygen is a typical case for many of the developing countries during the COVID-19 pandemic. At the peak, it was estimated that 500,000 people in developing countries required 1.1 million cylinders of oxygen per day. Although the worst times of the pandemic are behind us, the COVID-19 oxygen crisis remains as a brutal wake-up call and a sign for us to innovate and make changes in the current oxygen and purification techniques to aid developing nations.
So where exactly does purified medical oxygen come from? We currently rely on two major sources, PSA plants and cryogenic plants. In cryogenic distillation, atmospheric air made of nitrogen and oxygen is first liquefied at -269 degrees Celsius. It is then reheated to selectively boil off oxygen, which can then be stored and transported in tanks. There are three glaring problems with this approach: energy, cost, and time. Cryogenic coolers are both expensive and power hungry. A cubic meter of oxygen uses 1 kilowatt-hour of electricity. At the peak of India's COVID crisis, the country needed 5.6 billion kilowatt-hours a day to meet demand, which is greater than the 3.1 billion kilowatt-hours India uses on an average day. Transporting medical oxygen also adds to costs and causes delays. The second method is pressure swing absorption, PSA, where ambient air is pushed through a zeolite filter that binds to nitrogen but lets oxygen pass through. This system allows on-site oxygen generation, circumventing shipping costs and delays. However, the machine is costly to upkeep and produce. A PSA unit supporting one person requires up to $1.2 million to build and highly trained staff to maintain. Tragically, the current technology to make oxygen is outrageously unreliable. In our increasingly populous world, the market for safe medical oxygen continues to grow. In 2022, the global medical oxygen market was estimated around $4 billion and is expected to grow around $4.4 billion in 2023.
To navigate the red ocean of this ever-growing oxygen crisis and successfully create a lucrative, environmentally friendly, and life-saving product, we must redefine what it means to deliver oxygen. Instead of giving oxygen to a patient's lungs, Aether delivers it directly where it's needed, the vein. Our device is an artificial lung that purifies atmospheric air before bubbling it directly into a blood reservoir. This way, almost all of the available oxygen is taken up by red blood cells, making expensive oxygen concentration unnecessary. Our design pumps ambient air into a pressurized chamber, letting oxygen diffuse into the blood. The main challenge with this design is purifying the germ-filled ambient air before it makes contact with patient blood. To give patients the cleanest possible air, we use a combination of filters and chemical scrubbers that excel at destroying airborne biohazards. Compared with traditional air filters, chemical scrubbers are more heavy-duty and orders of magnitude cheaper. As precautions, we added a water bath to remove any trace chemical vapors and chose chemicals that can be safely disposed of. Either systems have major advantages over traditional methods. It does not need concentrated oxygen, it uses little money and energy to run, it is easy to set up, is gentle on the patient, makes clinical monitoring and care easy, and is also easy to produce and repair. Most crucially, it is low cost and can be transported in large quantities to the economically disadvantaged and rural populations that need it the most.
The current market for our product is hospitals located in countries in the midst of critical oxygen shortages, represented by the red and orange regions in this map. After we establish our product in locations with the most urgent need, we plan to expand our market to include more developed countries in which our product is used to lower the financial cost of oxygen production rather than for critical medical reasons. Because Aether is aimed to serve people first, we plan to develop it as a social enterprise. To improve the quality of lives by providing cheap, sustainable oxygen to those in the most need, a portion of our profits will be allocated to providing our product to those who may not be able to afford it. Our current manufacturing expenses sit at $49.45 per unit. Including shipping and marketing costs, expenses per piece increased to $80. We endeavor to sell 10,000 units in our first year and plan to see a return of 135%, creating $257,500 in net revenue. Allocating 20% of this to our social causes, we are left with $206,000 at the end of our first year.
Aether is the most efficient, affordable, and innovative medical oxygen provider in current markets and has the potential to forever remedy the global oxygen crisis. Help us change the world with Aether.